Welcome back for another topic in science. And this week we are going to be exploring the following topic in science: mixtures and solutions. So sit back and relax, but not too much, because I want you to make sure you got your books out and ready to go, because we're going to plow ahead today with our first of 2 days of notes on this topic: mixtures and solutions. In fact, what I'd like to do is today we'll talk about mixtures, and tomorrow we'll talk about solutions. So that will get us ready for Thursday's lab activity. So let's begin with the 4 classes of matter. I have provided pictures here of the 4 classes of matter because between this week and next week we are going to be exploring the 4 classes of matter. In the upper left we have mixtures, upper right solutions, lower left compounds. Elements and compounds we're going to talk about next week, and this week we're going to talk about mixtures and solutions. So why don't we begin today with mixtures, and I have a little video clip to share with you to introduce the idea of what mixtures are. So pay attention to this video. It's extremely informative, and I might quiz you on this, okay? So pay attention to this first video clip on mixtures. So here we go.
Go. Hi, my name's Karen. Today I'm going to teach you how to make fruit salad. Okay, here are the ingredients you'll need. Well, you can actually use any kind of fruit you would like. But here's the fruit I'm using. You can use some apples, blueberries, and strawberries. And should we pour it over?
Sure.
So I'm going to pour all the yogurt into a bowl. It doesn't come out. What out? What? The yogurt doesn't want to come out. I'm going to get a handful.
I'm going to get that outside too.
They're kind of hard to get just a handful.
Now that is disgusting.
That
It's yumma.
Yes.
There's apples in there?
Apples, blueberries, and strawberries.
Blueberry. You forgot blueberries.
I said blueberries.
Blueberries. Blueberries.
Oh, no matter how many times I watch that, I crack up. Blueberries, blueberries. Now, why in the world did I show you that? Well, because a fruit salad is a great example of a mixture. And so let's get started in our notes and simply begin with listing the 4 classes of matter. The first one we have already mentioned. It is the mixtures, and we're going to talk a lot more about mixtures throughout the course of the day today. The second class of matter are solutions, and as we will discover, solutions are a special type of mixture. And then next week we will pick up with elements, like this big hunk of gold here. Oh boy, wouldn't I want a hunk that big? That would be cool. And compounds. So tomorrow we will talk about solutions, and next week we'll discuss elements and compounds. But again, for today, let's get to mixtures. What is a mixture? Specifically, a mixture is a combination. And notice I've underlined certain words for a reason. Okay? A combination implies that things have been combined or put together. So a mixture is a combination combination of two or more substances that are mixed together but not chemically combined. Underline that word, not. Next week, it's going to become a lot more obvious to you when we start talking about compounds, chemical compounds. But for now, underline the word not, because mixtures are not chemically combined. What exactly does that mean? Well, I am getting hungry just thinking about these M&Ms. Do any of you like M&Ms? I know I do. Now, I'm curious if there's anyone as crazy as me. Well, all right, maybe not, but when I get a bag of M&Ms, there is a certain way that I like to eat my M&Ms, and I'm wondering if any of you do the same thing I do. Do any of you open up your bag of M&Ms and lay them all on a table and separate them by color, and then line up each color, and then count how many there are in each color of M&Ms? Do any of you do that? I've been doing that for many, many years, and I never tire of it for some reason. Although, when I was your age, we didn't have such colors as blue. We had different colors when I was younger. In fact, we didn't have instead of blue, we had light brown in addition to the dark brown. I don't know why or when they changed that, but anyway, we got some bright, brilliant colors here, and I still open up the bag, lay them on the table, line them up by color, and then you know what I do next? I take the line with the greatest number of M&Ms, and I eat those first until I get down to the next column of colors where I catch up and I start eating those. And I eat them all until I have just one of each color left. And then I eat them in rainbow order, Roy G. Biv. So I eat the red ones, then the orange ones, then the yellow ones, then the green ones, and then the blue ones. And I save the brown ones for last because they're the best ones of all, in my opinion. So do any of you eat your M&Ms like me? I wonder. Now, in that example that I gave you, however, that is a great illustration of what a mixture is. Because a mixture is made up of these individual particles or individual components, all different colored M&Ms, and you can separate out the different parts of the bag of M&Ms. You can take out all the green ones if you don't like them. Give them to me, because I'll eat them. I'll eat them all. But the point is, with mixtures, mixtures can be separated. And here's another thing. If you've got a bag of M&Ms and you've got 10 red ones, and somebody else opens up a bag of M&Ms and has 8 red ones, does that mean that one of those bags of M&Ms isn't a bag of M&Ms? No, of course not. They're both still bags of M&Ms, whether they have exactly the right number of colored M&Ms or not. It really doesn't matter because they really are all just as yummy as the other color. Colors don't matter when it comes to M&Ms. Well, let me give you another example here. How about my favorite staple food growing up, PB&J? Peanut butter and jelly sandwich. Do any of you still eat peanut butter and jelly sandwiches? Actually, I haven't had a peanut butter and jelly sandwich in years because I spent probably the first 30 years of my life eating nothing but peanut butter and jelly sandwiches for lunch. But now I have granola bars. Anyway, if you look at a PB&J, you know, it's got different layers. It's got bread on the top and the bottom, and it's got your peanut butter and your jelly. And you could have grape jelly or strawberry jelly. Do any of you have a preference? I like them both. Although I don't think I've ever had them both at the same time. That would be interesting. you know what, I might just go home and have a PBJ sandwich today for lunch and mix grape and strawberry. I'll have to report back to you and see if it was yummy or not. But here's the deal. Not everybody likes grape jelly. Some people prefer strawberry. Maybe you don't even like jelly, you prefer jam. Or maybe you don't like jelly or jam, just like peanut butter. Maybe you don't like white bread, maybe you like wheat bread. My question to you would be this. Are there different ways of making a peanut butter and jelly sandwich? Sure there are. You could use creamy peanut butter or chunky peanut butter. You could use the grape or the strawberry or other flavors of jelly as well. You could use different kinds of bread if you wanted to. But no matter how many different ways you make it, you could still call it a PBJ, a peanut butter and jelly sandwich, because there is no fixed proportion of peanut butter. When I make my PBJ, I like to add a lot more jelly than there is peanut butter because I got a major sweet tooth. And you know what else I do? I know some people might think it's weird, but I take my bread, and because I use so much jelly, jelly tends to bleed through the bread. So I put butter on my bread before I make the peanut butter and jelly sandwich. That keeps the jelly from bleeding into the bread. And it tastes good too. I still call it a peanut butter and jelly sandwich, even though I put butter in it also. Don't tell anybody, but that's how I make a PBJ. And I think it's just much more creamy and flavorful. And the bread doesn't get mushy from the jelly either. So my point is, you can make a PBJ in different ways and still call it a peanut butter and jelly sandwich. Well, all this talk about food is making me hungry. So if you need to pause the video to go have a snack, maybe some M&Ms or a PBJ, we're going to get into our notes here. Starting with this. We're going to discuss a list of properties or characteristics of mixtures. The first characteristic of mixtures is that their substances, whatever substances make up the mixture, they keep their individual identity. Make sure you write that word in there, individual, as well. But the substances keep their individual identity. Think of it in the context of our PBJ. When you make a peanut butter and jelly sandwich, is the peanut butter still peanut butter? Yeah. Is the jelly still jelly? Yeah. Is the bread still bread? Uh-huh. All of the individual substances keep their individual identity. You're eating M&M package. Are the red M&Ms still red M&Ms? Blue M&Ms still blue? You get the idea, right? Mixtures have substances that keep their individual identity. Number two, no new substances are formed. When you put peanut butter and jelly together on one sandwich, it doesn't create a new substance like ham. You don't make a ham sandwich by putting peanut butter and jelly together. I mean, that's just kind of silly nonsense when you think about it. It's against common sense. It's not the case when we talk about elements. That's why it's so important for us to understand and grasp these more simpler things this week. So when we make mixtures, no new substances are formed. Easy peasy, right? Here's another characteristic. You don't need to have fixed proportions in a mixture. And that's what I was saying before about like a PBJ. I add more jelly than peanut butter. But if you like more peanut butter than jelly, you could have more peanut butter than jelly. You could put butter on the bread like I do, or not at all. The point is, they're all still called peanut butter and jelly sandwich, even though there's no fixed proportion. It's not like you're following a cooking recipe when you make a PBJ. You don't have to measure out exactly 3 tablespoons of peanut butter and a quarter cup of jelly. That's like my peanut butter and jelly sandwich. But there's no fixed proportion. When you bake or cook, however, especially baking, if you've ever baked from scratch, you really do have to have certain fixed proportions or materials that are pre-measured out, specific quantities, specific volume, or specific mass. And the reason for that is that cooking and baking, they are chemical processes. You're not just mixing things together, you are performing chemistry. And if you don't have fixed proportions, well, you may not end up with a product that you wanted to end up with. Not so with mixtures. Mixtures, hey, if you don't like peanut butter, just have a jelly sandwich and it's okay. You're not going to die. You're still going to get a sandwich that you're going to eat if you like it. And here's one more point of mixtures. Mixtures, by their very nature, they can be physically separated. If you open up that bag of M&Ms and for whatever reason you don't like the blue ones, take out all the blue ones and you still have a bag of M&Ms. Just do me a favor and don't throw them away. Give them to me or someone else who likes any color M&M, because honestly they all do taste the same. So, properties of mixtures: the substances keep their individual identity. No new substances are formed. There is no fixed proportion, and they can be physically separated. Think of those 4 characteristics of mixtures when you think about a bag of M&Ms or a PBJ sandwich. They are examples of mixtures. However, technically speaking, there are really 2 different types of mixtures. And so let's explore these 2 different types of mixtures as we're writing this down in our notes, beginning with heterogeneous. Hetero is a prefix you're already familiar with from past topics. Hetero, as you know, means different. So a heterogeneous mixture is one that is different throughout. A heterogeneous mixture is the least mixed of all mixtures. And a good example of a heterogeneous mixture would be this: a tossed salad. I love salad. I love tossed salads. In fact, I have a salad pretty much every night with my dinner. Whether I go out to dinner or whether I eat in, I typically always have a salad because it's a good source of fiber, roughage, as they used to say, and a good source of minerals and vitamins, especially if you load it up with different vegetables. Preferably, in my opinion, preferably raw vegetables, because I think they taste better. Like everything about this tossed salad looks good to me. I like the lettuce, I like the carrots, I like the tomatoes. I don't mind having some onions sprinkled on as well, raw onions, sweet Vidalia onions. There is one thing on this salad that I don't like, however, as much as I've tried it in the past. You know what these things are here? Radishes. Radishes, to me, have a bitter bite to them that I don't prefer. So if I were to get this salad, you know what I would do? I'd take the radish off and fling it across the restaurant. No, of course I wouldn't do that. I only do that with olives. I fling them from the spoon. No, of course I don't do that at restaurants. No, I don't do it at home either. You shouldn't fling food around. That it could be dangerous, especially in the hands of a scientist who knows something about physics and flinging. You know, we know something about forces. No, okay. No, in all seriousness, however, I would remove the radish from my salad because I just don't like radishes. So if I remove my radish from my salad, does that mean it's not a salad any longer? Of course not. It's still a salad. It's still my tossed salad. It just has the ability to have individual substances that retain their identity to be removed and separated from the mixture. Why? Because a tossed salad is a mixture. If there's something on it you don't like, you can take it out. As opposed to, let's say, bread, for instance. Bread is baked, and it's got flour in it, it's got eggs in it, it's got salt in it, it's got all these ingredients, it's got yeast in it. So let's say you didn't like eggs, and you had a slice of bread. Could you reach into that slice of bread and remove the egg from the bread? No. Why? Because it's chemically combined in that bread. You can't just go in and remove it. So bread is not an example of a mixture. But a tossed salad, definitely an example of a mixture because you can separate the different parts. All right, I think you get the idea of a heterogeneous mixture. So how about a homogeneous mixture? As you may recall, the prefix homo refers to the same or similar. So homogeneous mixtures are those which are the same throughout. They look the same throughout. And homogeneous mixtures are very well mixed mixtures. An example here would be milk, believe it or not. Milk is a mixture of different things. It's a mixture of water, and calcium, and fat, cream. In fact, you could prove this that if you were to have some heavy cream, which is like fresh milk. Yeah, you know what? Let's take fresh milk. Maybe you are in an area where there are farms nearby, and you could get your hands on some fresh milk. Get some fresh milk, pour it into a glass like this, and let it sit for a while. You know what happens? You know what happens to it? It separates into layers. Now, if you're unfamiliar with fresh milk from the farm, either cow milk or goat milk, and your only experience with milk is buying it from the grocery store and pouring it into a glass, if you poured milk into a glass and you saw it separate into layers, would you be inclined to drink it? Probably not, because the milk you buy from the store has been homogenized. If you're bored one day, put in your fridge and look for the word homogenized. The word homogenized simply means it's been really well mixed together. So well mixed that it's not going to separate easily. But take that fresh milk, for instance. Here's a quick little story. Do I have time? All right, I have time for a quick little story here. Back in the old days, even before I was around, like my parents' age, people used to buy milk from a milkman. And the milkman would deliver fresh milk in the morning in glass bottles. And you'd put out your empty bottles, and they'd collect the empty bottles, and they'd give you a new set of bottles with milk in them. And that's how people got their milk delivered every morning. Kind of like newspapers are delivered. Well, none of you even read newspapers anymore because everything is digital. It's like getting your daily email. No, forget email. That's too old. Your daily Snapchat, Instagram, Twitter, tweet, whatever the social media is, you get your daily dose of something. People used to get daily dose of milk in the morning. All right, I'm digressing. So to the point of the story. Well, it used to be a chore for kids to go out and get the milk in the morning, bring it in, put it in the ice box or the refrigerator if you were really rich, to keep it cool for the day so that you could drink your milk cool. But in the winter time, it was a not a chore, but a treat for kids to go out and get fresh milk. The milk would sit in the bottle, and as I mentioned before, it would separate into layers, and the fat would rise to the top of the bottle and would begin to freeze in the cold temperatures. And that frozen milk fat would start oozing and pouring its way out of the bottle until it created a frozen mass on the top of the bottle. And you know what the kids would do? The kids would run out to be the first one that morning, if they knew it was cold, to bring the milk in because they would eat off the frozen fat from the top of the milk bottle. Now, some of you might be thinking, ew, that's gross, disgusting. Well, think about it. How many of you like ice cream? Where do you think ice cream comes from? It comes from frozen milk fat, folks, with different flavors added in, of course, but these kids were just eating their daily dose of ice cream in the morning for free. So milk, good example of a homogeneous mixture if it has been homogenized. Otherwise, fresh milk is a little bit more heterogeneous. Now, as far as homogeneous mixtures are concerned, they're not all the same. There are what are called colloids, and colloids are homogeneous mixtures where the particles are mixed but not dissolved. Tomorrow in more detail. But colloids, some examples of colloids include, Ready Whip, whipped cream. Let's see, you can see these other examples, list here, clouds, gels, fog, aerosols, milk, some forms of milk, foams, smoke, emulsions are all examples of colloids. My favorite is whipped cream, where the cream is dissolved but not, mixed but not dissolved in the air bubbles that make the whipped cream. You can make homemade whipped cream, by the way, too. Did you know? If you take some of that milk fat and you just shake it and shake it and shake it, or you whisk it, it actually turns into whipped cream, which is really tasty, too. Keep on shaking it and shaking it and shaking it after the cream, and it actually turns into butter. I would love to do that activity with you. Maybe you could do it at home for some bonus points. Get some heavy cream, put it into a jar, close the jar real tight, or like an empty milk bottle or an empty water bottle, one of those 500 milliliter water bottles, they work great. Pour some milk cream in there, tighten it up real good, and just keep on shaking. It'll take maybe 10 minutes or so, but then you can cut open the bottle and have some, delicious, fresh butter. All right, I'm getting hungry with all this talk of food, so let's move on to the last slide for the day, which are solutions. Solutions is a special type of mixture where the particles are dissolved. And hot chocolate, great example of a solution. Now we're going to spend all day tomorrow talking about solutions. So with this talk of this cream and hot chocolate and all this other good stuff, M&Ms, my mouth is literally watering right now. So I'm going to have to go have a snack. So for now, I'm going to say bye-bye.